Okay, so we're just going to go over a lesson on Chapter 5, dealing with Aufbau diagrams and also other electron configurations. So just as a review from today, electron configurations are based on three principles or rules. Okay, the first being the Aufbau principle, and that states that electrons occupy the orbitals of lowest energy first. So what that means is when you go to fill these Aufbau diagrams, you're going to start from 1s, and then you're going to travel all the way up to 8s, actually. As I mentioned in the lesson, this only goes to 6s. But this is increasing energy, so you have to enter your electrons starting with the lowest energies first. Okay, so that's all that one is saying. The second principle is called the Pauli exclusion principle. And that states that an atomic orbital may have at most 2 electrons. Either 1 or 2 electrons may occupy an s orbital, and to occupy the same orbital, 2 electrons must have opposite spins. So again, looking at this, you would go ahead and you would fill in 1 or 2 electrons in each of these boxes. So each of these boxes are basically, these are examples for orbitals. Okay, so each of these boxes is an orbital, and so you would put 1 or 2 electrons at most in each of these orbitals. Now, depending on the different sublevels, for instance, the s sublevel can only hold 2 electrons total. Okay, it doesn't matter how high they get in energy, they can only hold 2 electrons total. Now, the p sublevels, 2p, 3p, 4p, etc., they can each hold 3 orbitals, or 3 times 2 electrons each, 6 electrons. So the p orbitals always, the p sublevels can always hold 6 electrons. And then also you have your d sublevels. They can hold, so they have 5 different orbitals in each. They can hold 5 times 2, 10 electrons. What I don't have on here is the f. Okay, so if I had an f sublevel, I would have 7 different boxes together, and that would hold 7 times 2, 14 electrons. Okay, so the second part of this says that to occupy the same orbital, 2 electrons must have opposite spins. Okay, so that just means that when you have your orbital, okay, you are going to show a spin going clockwise and a spin going counterclockwise. And I mentioned in class that you can just show it like that. You don't have to show the full arrows. I'm not really sure where the shorthand first came into play. I mean, it doesn't take you that much time to draw a full arrow, but I just think it's very easy when you do the half arrows, because if you go up, you know, if you're going to fill up an orbital, you could go 1, 2. And then you just go 1, 2. It doesn't really matter, but I would accept either. All right, so 2 electrons in opposite spins, one going up, one going down. And lastly, you have Hund's rule. So Hund's rule states that electrons are filled into orbitals singly first, and then paired once orbitals have at least 1 electron. Okay, and all that that's saying, okay, is that as you go up the different energy levels, you're going to fill an entire sublevel before you go on to the next one. And that also is saying that if you are to fill these, so for instance, let's say I filled this one, I filled this one. Let's say I need to fill only part of the 2p sublevel. I have to fill them in this way. So I go across the sublevel, and if I have more electrons, then I would go to fill them in like this. Okay, so they need to all be filled in singly first. That's what that means, as a single electron with a single spin. And then once they're all filled, then you can pair the orbitals with the second electron. Okay, so in the case of, let's choose an element up here. In the case of not neon, but let's do potassium. Potassium has 19 as its atomic number. So if potassium has 19, you would fill in arrows totaling 19. So let's just say we already finished these. So 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so that would be potassium because potassium has 19. And just like in class, and I will show this in the practice problems, but you would go ahead and you would write the element, in this case potassium. It has atomic number 19, therefore it has 19 protons, and if it's a neutral atom, in this case it is, it also will have 19 negative charges or 19 electrons. And then in order to fill out your electron configuration, you would just go ahead and write the number. Okay, you'd show the shell or principal quantum number. You'd also show the subshell letter, and then you'd put a little exponent denoting how many electrons are actually inside of that orbital. So in this case, I would have 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, because I only have 1 in there. So I could go ahead and fill that in up here. Okay, and so in the practice problems we go over 3 different elements, and I would definitely recommend going over these in case you need more help, and you can constantly repeat them if you like. If you have any questions, like I said before, please go ahead and see me after class. You can make an appointment. All right.